Hey, Mr. Murray here on Mr. Murray's Mathland, taking a look at another classic FRQ topic on the AP exam, and that would be motion problems, velocity, position, acceleration, distance, displacement, speed, all that good stuff. And this is very commonly one of the 6 FRQ questions on the exam, so definitely worth knowing all the questions associated with it. And we're given the velocity here, and it can be given as an equation, as I've chosen to look at here, but it could be given in the context of a table or a graph, but all the core concepts are the same. So I'm going with what I think is the most common, that being the equation of the velocity of an object is given. In this case, we're talking about a particle that's moving along the x-axis, so it's moving right and left, and it's at a position of -3 at the time t equals 1. Or, as you often might write it, x of 1 equals -3. Okay, and we are approaching this as if it's on the calculator section, and so it's also going to be a chance to brush up on some of those calculator topics and little tricks and how to do things. Okay, so right off the bat, part A says at t equals 1, this time which we've been given its position, is the particle moving toward or away from the origin? And so just a little visualization of what you've got going on here, that there's the origin on the x-axis, and at t equals 1, it's at a position of -3. So the particle is sitting right here on the x-axis, and you really just want to know, is it moving toward the origin, or in other words, is it moving to the right, or is it moving to the left, which would be away from the origin? And notice the position is just as important as the direction of movement, because if they had given you the position started somewhere to the right of the origin and you were moving to the left, that would cause you to be moving toward the origin. So both things are important here, the direction of movement and where we started from. So let's bring in the calculator to take a look at the velocity, because that's going to tell you whether you're moving right or left, right? If your velocity is positive, you're moving forward or to the right. If your velocity is negative, you're moving to the left or backwards. So here is the calculator. I have already put in the velocity function in y1 because I'm probably going to use it multiple times for a variety of questions. And if you're wondering how I made it look like that nice nice fraction where I didn't have to use extra parentheses and all that, remember that's the fraction feature which is in the F1 menu. So alpha y equals, and it's right there, n over d. So I'm just going to quit that and go back there. I just want to show you that. So here's my graph. I'm just going to bring up the graph. And I did adjust the windows from 0 to 6 on the x-axis. And I want to know basically which direction is the particle moving at t equals 1. So I'm just going to turn on the trace and tell it to go to 1. This is the velocity function. And so the velocity at 1 is 0.787. So that's going to be part of my response here, is that the velocity at 1 is 0.787. And notice I'm using proper notation. It's a great way to communicate from shorthand and still get full credit and justify things. And so what does that tell you? It tells you the particle is moving left. Whoa, excuse me, is moving to the right. Whoops. Positive velocity. It's moving to the right. And since we were starting at -3, we're starting to the left of the origin. So I'm going to basically just include that in my response. Since the particle is at x equals -3 at t equals 1, and moving right, it is moving toward the origin. So always want to make sure your answer is clear and that you've justified it, and that you have to say something about the position and the direction of the particle to get credit on this one. Okay, so there's that. Question 1 answered. Very good. Now let's take a look at another question, or another couple parts with the same given velocity function. Same original information about the position. Find the acceleration of the particle at t equals 2.5. So in general, if you're looking for the acceleration, 2.5, and you have velocity, right? Acceleration is the derivative of velocity. So I'm looking for v prime of 2.5. And sure, you could do the derivative of this by hand. It would be a quotient rule, and it wouldn't be the worst thing in the world. But you've got a calculator. You should know how to use it to get the derivative at any given moment. That's one of the features you want to be familiar with. So I'm going to bring this right back up. And if I'm on the graph, there's a way to get that by going to second, trace, and item 6, that dy dx, the derivative feature on the graph. The calculate menu is where you find all the things you want to do on the graph screen. So when you bring this up, you just have to tell it what x value you want to do it at. It doesn't ask you for it. I always thought it should. But so second, trace 6, and then tell it 2.5, and now you can see, hey, at this spot, dy dx is 9.3957. And so your answer, it has to be accurate to 3 decimal places, which means you could actually go beyond 3 if you're not sure about the rounding or truncating, but you could round this to 396, or you could truncate it to 395. They're both acceptable. So very easy, right? A lot easier than doing it by hand. And when you're in the groove, you can move through this kind of stuff pretty fast. Okay, so now part C says, at that same moment of 2.5, is the speed increasing or decreasing? So you just found that the acceleration at that moment was positive, but as hopefully you may recall, to talk about speed increasing or decreasing, you want to know about velocity and acceleration. They both need to be considered, and whether or not they have the same sign or different signs. Are they both positive, both negative, or one positive, one negative? So we've already found what the acceleration is. I don't need to re-find it or even re-say it, but I'll probably allude to it. But you do want to mention what is velocity of 2.5. Or at least say whether it's positive or negative. And you can actually see at that same spot on the graph, they've given you the y value, which is the velocity at that moment. So velocity of 2.5 is about negative 0.744. And since the acceleration was positive, which we found in part B, but the velocity was negative, different signs mean that the speed is decreasing. And so you just got to say something about that you consider acceleration and velocity. They both need to be mentioned in your justification. So since A of 2.5 and V of 2.5 have different signs, or you could specifically say, since one's positive, one's negative, whatever, that means the speed is decreasing. Right? Okay, so that's again a classic kind of question asking about speed increasing or decreasing. Know what you're looking for to answer that. You need to know velocity and acceleration having different signs or the same sign. Okay, part D and part E. I mean, longer than a real free response would probably be, but I'm just throwing in a lot of the classics here. Part D, find the distance traveled by this particle from 1 to 5. So distance traveled, unlike displacement, is you want to integrate from 1 to 5, but distance is not taking into consideration whether you're moving forward or backward, right or left. It's all distance traveled, so you want to take the absolute value of velocity. Notice you got to have the proper notation there, the differential on the end there, dt. And you can use shorthand, use v of t. And now to do this on the calculator, I'm going to bring this up. This is sort of one I think I'm going to do on the home screen. So I'm going to quit second mode. You can always get back to the home screen that way. Math 9, which is the integrate feature, from 1 to 5. And to bring up those absolute value signs, which you need from time to time, those are sometimes tricky to find, but go to the math menu where a lot of stuff is and scroll to the right to the number column, absolute value of, and now you can either type that equation, or if you've put it in y1, know where to find that y1. Alpha trace, that's the F4 menu, that's y1, or you can go to vars and y variables. But nice to know these little shortcuts, big time savers on the AP exam. And there we go. Now I'm just going to hit enter, let the calculator do its work. Okay. 5.205. Okay. And part E says find the position of the particle at t equals 5. Now don't fall into this trap and think you just found the distance traveled from 1 to 5 and you know where the particle was at 1. Right? I know that at 1 the particle is at a position of -3. Just don't be fooled and think, oh, I can add on that distance traveled and that'll tell me where I was, because that distance traveled takes into consideration all the motion, forward, backward, right, and left. And what you want is the displacement. So you want to take this relationship of, if you want the position at 5, you want to take the known position at 1 and add on the displacement, which is very similar to distance traveled, but without the absolute value. And that way it will take into consideration, hey, if it was moving to the left, that's taking away from its position. That'll tell you where you are. So I'm going back to the calculator here. And I'm going to do x of 1, which is -3, plus math 9 from 1 to 5, from the position you know to the position and time you want, and no absolute values this time. Alpha trace y1 dx. And so if they ever ask you for just displacement, then you would just want that integral. That would just be the change in position from 1 to 5. And you can see we actually ended up at a negative. It was not moving forward, all that much. So x of 5, after all that, is approximately -5.589. And you certainly don't have to box your answers, by the way, to get credit here. It's just something I like to do. Okay, let's take a look at the last couple problems here, which is this, and this is to illustrate the difference between these two, either one of which might be asked. You have a velocity function, and this says find the average velocity, over a particular interval, in this case from 2 to 6. So if you have a velocity function and you want the average velocity, that's like asking for the average value of this function. For average velocity, average v of t, if you want the average thing that you already have, you want the average value. So this is the average value, what we're about to do, of v of t. And that is 1 over 6 minus 2, which is 4, taking 1/4 of the integral from 2 to 6 of v of t, right? Finding the area under it and then dividing it by the base. Finding the area, which is 2 to 6, that integral, and then dividing it by 4 to get that average height, that average value. So bringing the calculator back, because I certainly don't feel like doing this, and 1/4 or 0.25 times that definite integral. So math 9 from 2 to 6 alpha trace y1 respect to x, and here we go. And by the way, I don't know if I mentioned it or not, so I'm just going to say it again. This function had a trig function in it, cosine. So make sure you are in radian mode for calculus, always radian mode. Even if you're in physics class, you might be in degree mode, so just always want to watch out for that. So this would be approximately negative 0.191. And there we go. There's our average velocity. And the final question is, what's the average acceleration? So if you have velocity, doing average acceleration, well, you could think about it the same way if you want, of doing the average value of the acceleration function, but you don't have the acceleration function, so that would be like taking the derivative of this and then getting the acceleration and then integrating it to do the average value of it. But what you really should be able to come up with is, since acceleration is the rate of change, we want to do the average rate of change, the AROC of v of t, not the average value of it. And that, of course, would be v of 6 minus v of 2 all over 6 minus 2, which is doing the average value on the acceleration function. You know, there's the 1/4, and this numerator represents integrating the acceleration function, getting velocity of 6 minus velocity of 2. All right, so let's bring in the calculator to do this for us. And so here's how I'm going to make that nice fraction. So alpha y equals, and you know, up top v of 6, well, I can just accomplish that, remember, with these little tricks. Alpha trace, that's like writing y1 of 6. You just got to add the parentheses, minus alpha trace y1 of 2 divided by 6 minus 2. I think I can handle that without the calculator, but you never know. And hit enter, and there we go. 0.977 or 6. I prefer to round instead of truncate, but both are acceptable. And so there we go. That's it for classic questions here. I went overboard and had a few extras, but I just couldn't stop myself. You know, it's hard to stop when you're having fun. But hopefully you've seen some, and there's always more kinds of things and twists and turns they can ask. But those are a lot of the big ideas that can just branch off from just one simple scenario of being given the velocity. So hopefully this cleared up a few things if you had any questions. And if you have any more, always feel free to ask. And as always, keep working hard, kids.